Okay, so with a graph here, a sine graph from 0 to 360, we should know that a normal sine graph starts at 0, then goes to 1, goes back to 0, down to -1, up to 0. So it should look something like that. However, the use of this 4 means it's going to be vertically stretched. So it's going to be stretched by a factor of 4. So instead of it going up to 1, it's actually going to go up to 4. Now, because we're sketching it, it doesn't overly matter too much what it looks like. Because we've got no scale. But let me try and set something out here. Just so I can get it as nicely as I possibly can. Okay, so it looks something like that. I'll just delete this line. And down like that. And it will go between, so instead of going between 1 and -1, it's going to go between 4 and -4. Now, if you're not certain, what you can do is to put in your values of 0, 90, 180, 270, 360 into here. And if you do 4 sine 0 into your calculator, it will give you 0. If you do 4 sine 90, so this one into your calculator, it will give you 4, and so on and so on and so on. So you can always check with your multiples of 90. So if you've drawn this perfectly, you should have a perfect symmetry. So there's a line of symmetry down the middle of this curve. There's a line of symmetry in the middle of this curve. The curve at the top is exactly the same as the curve underneath. It's just it's been rotated. So any symmetry that we find up here can be repeated in down here. Okay, so let's have a look. We want to find all the solutions of the equation 4 sine x equals 1. So that's the same as having sine x equals a quarter. So we've got the graph of 4 sine x. That's 2. This is 1. So if I draw a line across at 1, typical, missed it, hang on. It's not letting me doing this. There we go. Okay, so if I draw a line across at 1, you can see it cuts the curve in 2 places. One's there, one's there. Now, because of the nature of the curve, this would go up again and back down. So it would cut again there and there and an infinite amount of times. Now, your calculator can't store an infinite amount. Your calculator can store one of these solutions. So what we're hoping for is that one of the solutions that it stores is one of the values that we have. So let me just move this into... It doesn't want to play ball with me today. Okay, so you got one solution there and another one there. So let's figure out what this is going to be. So we're going to inverse sine both sides. So if I do inverse sine of a quarter is 14.5. So because this solution here is between 0 and 90, that is actually your 14.5. So we can now use the symmetry of the curve to say, well, if the gap between there and there, between 0 and our solution is 14.5, then using the symmetry over this side, this gap here has to be the same size. That also has to be 14.5. Except whereas this one is 0 plus 14.5, this solution is 180 minus the 14.5. So we get 14.5 and 180 minus the 14.5, which gives us 165.5.